All right, everything up to this point in this chapter, we've had right triangles to deal with, even with our special 30, 60, 90 and our 45, 45, 90 right triangles. Then we didn't have those special angles, but we still had right triangles. We could do SOHCAHTOA. Notice this triangle right here does not have 90 in it. Even though we have those two angles right there, 80 and 40, if you add those together, that's 120. And then that leaves 60 degrees left over for this one. You see, I don't have a right triangle. So we're in trouble. There's two different functions that we'll use this chapter. One of them is called the law of sines. That's what we'll do today. The other one's called the law of cosines. That'll be next time. So let's just take it one thing at a time. If we don't have a right triangle, we could possibly use the law of sines. And even though this looks messy, it's going to be way easier than you think. Here's how I know which one to use between the law of sines and the law of cosines. It's about in the triangle that they see you, how many side lengths do you know? And you see on this one, we know one side. The word sine sounds a lot like side to me. So it's like one sine, one side. We'll learn next time that cosines, co means more than one. You'll have more than one side, but today, just one side right here. So here's what we do. We need to set up this little proportion. You won't actually do all three of them. You'll just do two of them. But they're just saying that all of these ratios are proportional to each other. Here's the simple thing. If you buy into this, circle the side that they gave you and draw an arrow to the angle right across from it. We will set up a function where the sine of that angle measure is over that side length, right? It's like big A over little a, like those are the angles and the sides that correspond with each other. That will be proportional to, if we do that again, if we circle the side and go to the angle across from it, it'll be the sine of 80 over x. And the first question you might ask yourself is, how the heck did you know you used the sine instead of the cosine or the tangent? That's because this guy's name will be the law of sines. Every time we will use the sine function in this one. And what's cool about this is just a straight up proportion we solve with cross multiplication, baby. So I'll take x times the sine of 40. Notice I wanted to put that first and put the sine of 40 last. That will equal these two dudes times each other. We'll do 12 times the sine of 80. Instead of having like sine of 80 times 12, which looks messy and people might want to multiply those together and you're not allowed to, put the number first and the trig function part second. So we got this all cross multiplied. Remember, we're just trying to solve for x, right? And there's a stupid times sine of 40 with that. We will just divide both sides by the sine of 40. So I'll show baby steps. I'm not saying you have to, but this is what we're going to do to both sides. We're just going to divide by the sine of 40. And those like cancel each other out to where you have x equals this guy right here. And you would think that maybe you could reduce those to be like the sine of 2 because like 80 over 40 is 2, but it doesn't quite work that way. So punching this in can be confusing on a lot of different calculators. So here's what we'll do. I'm going to kind of just have this to the side here. We'll first just do the numerator. Do you see it's 12 times the sine of 80? And I'm going to close that parenthesis and just hit equals. But I'm not going to round that guy off because I still have to divide by the sine of 40. Now, I'm not saying you have to punch it in this way. I totally would punch it in this way because it works on everybody's calculator if we do it in this order. Like, just do the numerator, hit equals, then divide by the denominator, and I got about 18.4. So x is about 18.4 is how long that dude is in that case. Why did I use the law of sines? Great question. I don't have a right triangle, so I realized I just had one side. Next time we'll deal with something that has more than one side, so let's try that again. I'm going to talk myself through it like it was the entire chapter. First thing I want to know is this guy special? Is he like 30, 60, 90, or 45, 45, 90? Nope, I don't have those angle measures. Then I want to know if I can do SOHCAHTOA. I have to have a right triangle for that. I don't. That's 91 degrees, right? So it's down to the law of sines or the law of cosines. All we know so far is the law of sines, and that's how many sides they gave you. One side, right? The other one, I know there's an x there, but we don't know him, right? One side, one sine. So we'll take our picture and we'll circle the side they gave us, and uh-oh, we draw an arrow to the angle across from that, which they didn't tell us. But with our calculator right here, we can totally find it, because remember, all three angles add up to 180. So 180, take away 91, take away 52. That angle right there has got to be 37 degrees. So we'll put it in the picture, please. 37 degrees, and we'll set it up. Who goes next to the trig function every time? Is it the angle or the side? It's the angle. So the sine of 37 over 20 will equal, and I'm telling you, if you draw these arrows, it just makes life a lot easier. You circle the side length. This one's x, that's what we're trying to find, and draw an arrow across to him, and that will be the sine of 52 over x. This is the hardest part. It's setting up the proportion. It's like, okay, who's going to be proportional to each other? Once we get this, it's gravy, baby, because we just cross multiply. All right, it's going to be x sines of 37 equaling 20 sines of 52. And then our move is to get rid of this. There is a times sine of 37, so x is going to equal this whole thing over here divided by the sine of 37. So we get it all set up by showing that work, then we punch it in the calculator, baby. I'm going to do the numerator first, so clearing all this stuff out. 20 times the sine of 52, hit equals, and then we will divide that by the sine of 37. Notice I didn't round anything off or anything. I'm just keeping that number, and that's our final answer. That's what we want to round. So x is about 26.2. Yes, again, your calculator has to be in degree mode. He is not degrees because we're not finding an angle measure. We're finding a side length. So law of sines. One more time, why are we using the law of sines? I don't have a special right triangle. He's not 30, 60, 90 or 45, 45, 90. And I don't have a right triangle. So I need to realize how many sides do I have? One. I just have one side. So that means we're going to use one sine, the law of sines, as opposed to cosines, which means more than one. So using my calculator, I'm going to go figure out what that missing angle is. 180, take away 34, take away 84. That guy right there is 62 degrees. So I'll set him up. The law of sines says you'll always use the sine function. So those two bad boys go together, and that will be proportional to these two guys. Circle your side length, draw an arrow to the guy across from him, the sine of 84 over x. Again, this is the angle measure. It got to go next to the sine part. Now let's cross multiply. So x sines of 62 should equal 16 sines of 84. And then x will equal 16 sine of 84 all over the sine of 62. And we just simply punch that in, nice and neat. Numerator first, 16 sine of 84 equals, divided by the sine of 62 equals. About 18.0. Yes, we will put the 0.0 because they want us to round to the nearest tenth. That's pretty much the law of sines in a nutshell. Now let's go do some story problems where it could be any of them, right? I might have SOHCAHTOA in here. I might have special right triangles in here. So let's see which ones we got. So a geologist finds an outcropping from an underground rock formation normally indicates the presence of oil. So boys are going to deal with some oil here. The formation dips another 17 degrees from the surface. If an oil well is placed 1,000 meters downhill from the outcropping, so here's the outcropping and here's the 1,000. They kind of have that in the picture for us right here, but that orange thing is 1,000, and you see they have this orange triangle formed going on right there. So they say, how far will we have to drill underneath that to find the oil? They're asking us to find x right here. So here's what we got. We got a 17-degree angle right there. So this is a tricky one because we can't even do the law of sines yet due to the fact that we only have one angle measure provided. So we had to use this little fact right here, that this is not the straight edge I was looking for, but this guy right here comes out and will go like straight down and make a little right triangle with us. And this entire angle up here is 17 plus 8, right? 17 plus 8 is 25. This guy is 90 degrees, so that will allow us to find this dude down here. If that's 25 and that's 90, we would have 180 degrees total. Take away the 90, take away the 25. This dude down here is 65 degrees. So this is a tricky one that we had to go find that angle up there. That's why they gave us this 8-degree thing going down, right? So if we get rid of all this stuff right there, this 8 degrees going down and that 17 degrees going down further. So that was a good problem right there. Now we can use the law of sines to figure this guy out, because we still have one side length. I got this 1,000 with the 65-degree angle, so I'll do the sine of 65 over 1,000, and that will equal, if we go with the x, let's use green so we can see stuff here. X is this side. He's across from that 17, so the sine of 17 over x. What a cool, tricky problem that is. So that's the hard part, is we had to find that guy. I was like, why did they give us this 8 degrees? We needed to use that, assuming we had a 90 right here. Right? So cross multiply, and 1,000 sines of 17, and then x will equal 1,000 sines of 17 divided by the sine of 65. And we'll go punch that in. 1,000 sines of 17, hit equals, divided by the sine of 65. Sorry for the bad handwriting. And I got about 322.6. Is that what they wanted us to round to? So sure, 322.6 meters deep is what that would be. Probably possibly could round it to 323 meters also. So we'll just see what that says. But that's a good one right there. And then I shouldn't say the last one, there's another one. 3 cities form the vertices of a triangle. The angles are 40 degrees, 60 degrees, 80 degrees. So let's draw that with shape 2 on our geometer. And like I'm going to just kind of put like A, B, and C on there just to label the cities since they don't do it. The 40 degrees is the smallest of these 3 angles. So this is just like an inaccurate picture right here because I just used shape 2. So 40 degrees, I put in the smallest looking angle. 60 degrees going right there. 80 degrees I put right there. So just putting the 3 angle measures in there. It says the 2 most distant cities, so our cities are A, B, and C, are 40 miles apart. Well, we need to use the fact that the farthest apart would be the longest side, and shouldn't the longest side be across from the largest angle? So I'm going to put a 40 right there, and I'll throw miles on it as well. How did I know that had to go there? Because they were the farthest cities apart, and the longest side is always across from the largest angle. They say how close are the closest 2 cities? Well, wouldn't that have to be this, the guy across from the smallest angle in that case? So what should I use? Well, I don't have a right triangle, so let's use the law of sines. So this 40 is across from the 80, so I'll do the sine of the angle measure over the side length, and that will equal, again here, bada boom, the sine of 40 over x in that case. So cross multiplying, x sines of 80 will equal 40 sines of 40, and then we will divide. X will equal that 40 sines of 40 over the sine of 80, and we go punch that in. 40 sines of 40 hit equals divided by the sine of 80, and I got about 26.1 miles. So x is about 26.1. They did say round our answer to the nearest tenth of a mile, so I got that. And lastly, these are the last two. They say solve for x. Well, bro, we better talk ourselves through it and see, first of all, if this is special. Anytime we have a special triangle, we will use the rules. That is our 30, 60, 90, or 45, 45, 90. I do not have that. Then I want to know if it's a right triangle, and boom, this is a right triangle, so we can use SOHCAHTOA. SOHCAHTOA will be one of the easier ways to do this. So focusing on this angle measure, this guy is adjacent to it, and this guy is the hypotenuse. So we'll set it up. Adjacent and hypotenuse is the cosine. So the cosine of the angle measure equals adjacent over hypotenuse. And then we will get rid of the divide by x by multiplying both sides by x. And then we get x by itself by taking both sides and dividing by the cosine of 18. So 9.2 divided by the cosine of 18. And I got that side to be about 9.7. X is about 9.7, which does make some sense. He should have been longer than 9.2. So sweet. And then the last one of the day is, first, is he special? This is 30, this is 90. That bad boy had to be 60 degrees. So yes, indeedy do. He is special. So then I asked myself, who is this 12? Is he the short leg, the long leg, or the hypotenuse? He is across from the 30, so he is the short leg. That is the key to the puzzle. So that means to find this guy, which is the hypotenuse, he is twice as long. So 24, baby. No work needed. Yep, you probably could have used the law of sines on that. Yep, you could have used SOHCAHTOA, but we are just memorizing some cool shortcut rules for that. So, and let us know if you have any questions. Have a good one.